Hello friends, welcome to my channel Master the Monster. Let's enter into the world of polynomials. Trust me, this is going to be an easy and interesting section of mathematics. You may have few doubts and questions regarding polynomials, the degree of polynomials, zeros, division of polynomials, what are quadratic polynomials, geometric meaning, all those things in your mind. No worries, let us sort out all the questions one by one. Before that, subscribe to my channel so that you will enjoy learning maths. Class 10 Cbse Maths Chapter 2 Polynomials Exercise 2.2 Problem number 1. Find the zeros of the quadratic polynomials and verify the relationship between the zeros and the coefficients. So here in this problem you are given few polynomials, say p of x. Okay, you are given some 6 polynomials. In each case, you have to find the zeros of these polynomials. And you see all these polynomials are quadratic polynomials, so they have at most 2 zeros. Let them be alpha and beta. So now we have to find what are alpha and beta. Okay. So find the zeros of the quadratic polynomial and verify the relationship between the zeros. And we know that the relationship between the zeros is alpha plus beta equal minus b by a and alpha beta equal c by a. So we have to verify these two relations also. So in this problem, we are going to find the roots alpha and beta of the given polynomials, and we are going to verify whether this alpha plus beta equal minus b by a and alpha beta equals c by a in each case. Right? Do you understand? I am going to proceed this problem using the splitting method to find alpha and beta. And we have seen the clear explanation of splitting method in our previous video. I have given the link of it in the description box. You can go through it before you start solving this problem, right? So that you will understand the method in a better and clear way, right? Okay, now let me start with the first subdivision. In the polynomial given in the first subdivision is x square minus 2x minus 8. And let me compare it with the general form of quadratic polynomial, that is ax square plus bx plus c. So that I get a equal 1, that is the coefficient of x square. B equal minus 2, that is the coefficient of x. And c equal minus 8, which is the constant term, right? Okay. Now let's apply the splitting method. The first step in the splitting method is to find two numbers L and M whose sum equal B, that is minus 2, whose sum equal the middle term, and product equal A into C. See, A into C means it is 1 into minus 8, so it is minus 8. So now we are going to find two numbers whose sum is minus 2 and product is minus 8. Okay, now factorizing 8, we see, first we'll factorize 8. So factorizing 8, we see that 2 4s are 8, okay? But you need a minus sign, right? So any one of these factors, either 2 or 4 should be negative so that you get the product to be negative. But you see, before applying the sign, you check the sum also. If the sum is also negative, then please place the negative, that is negative sign with the bigger number so that you get the two numbers to be correct. Okay. So here you see the product 2 into minus 4. It's minus 8. And 2 minus 4, the sum is minus 2. Right. So we got the two numbers. Now the next step is to split the middle term. Split the middle term. Here the middle term is minus 2x. Let me split it as 2x minus 4x. So it's plus 2x minus 4x minus 8. So the first and the last term remains the same. The middle term alone I have split it as 2x minus 4x. The next thing is to group the terms and get the factors. So I'm going to group the first two terms by taking x common outside so that I get an x plus 2 remaining. And the next two terms, let me group them by taking minus 4 common outside. So again I get x plus 2 remaining. From these two terms, we can take x plus 2 common outside because you have an x plus 2 here and an x plus 2 here. So that I get x minus 4. So now we have got the two factors of this quadratic polynomial, namely x plus 2 and x minus 4. Now our next step is to equate these factors to 0 and get the roots. So the first factor is x plus 2, equating it to 0, I get x equal minus 2. The next factor is x minus 4 and equating it to 0, I get x equal 4. Therefore, minus 2 and 4 are zeros of the given polynomial. Given, right? Okay. So this is how we find the rows of a polynomial using splitting method. So first part of the problem is over. The next part is that verify the relationship between these zeros. So now let's go to alpha plus beta equal minus b by a and alpha beta equals c by a. Okay, now let's take, we have got two roots alpha, 2 minus 2 and 4. Let me take them as alpha and beta. Now we'll see what is alpha plus beta. Alpha plus beta equal, it is sum of roots. So it is minus 2 plus 4, that is equal to 2. Okay, so alpha plus beta equal 2. So this alpha plus beta should be equal to minus b by a, isn't it? So let me see what is minus b by a. Minus b by a is minus of b here is 2. I'm sorry, it's minus 2 divided by a is 1. So it is minus of minus 2, that gives me 2. So I have got alpha plus beta equal 2 and minus b by a equal 2. Therefore, we have verified the first relation. Next, let's consider the product of roots, that is alpha into beta. Alpha into beta is minus 2 into 4, that gives me minus 8. And this should be equal to c by a. Let's verify whether it's equal or not. So let's take c by a. This c by a is equal to c here is minus 8 and a here is 1. So minus 8 by 1 is minus 8. Yes, they are equal. Alpha beta equals c by a. So this is how I have found the root, found the zeros of the quadratic polynomial using splitting method. And also I have verified the relation between the zeros of the polynomial and the coefficients of the polynomial. So this same procedure I am going to apply for all the remaining polynomials also. Right? We understand the first subdivision clear so that you can cope up with the speed of the next polynomials, right? So let's pass on to subdivision 2. Here subdivision 2 is 4s square minus 4s plus 1. So comparing it with the standard form, I have a equal 4, b equal minus 4 and c equal 1. Now we have to find two numbers whose sum equal minus 4, that is b, and product equal a into c, that is 4. So we need two numbers whose product is 4 and sum is minus 4. Okay, now 4 can be factored as 2 into 2. So product is okay. But see, what about the sum here? The sum is negative. That's minus 4. So you need the terms to be in negative case. Suppose you take one term to be negative, then you see you don't get the product as 4. You get it as minus 4 and also the sum will be 0. So both the cases are not satisfied. So let me take both the terms to be negative so that I get the product is positive. So both the numbers should be negative. And sum is negative. So again it satisfies when both the numbers are negative. So now I've got two numbers whose sum is minus 4 and product is 4. Using this, I'll split the middle term of the polynomial. 4s square minus 4s plus 1. The middle term here is 4s and I'll split it as 4s square minus 2s plus 1. Now let me group the terms. I'll group the first two terms by taking 2s common outside so that I get the remaining term to be 2s minus 1. From the next two terms, you don't have any common numbers. Let me just take the minus sign outside so that it is minus 1 into 2s minus 1. Okay, now we have got 2s minus 1 common in both the terms. So let me take 8 common outside, 2s minus 1. So the remaining will be again a 2s minus 1. So this is how I have factored the given polynomial into two factors. Now equating them to 0. The first factor is 2s minus 1 equals 0. That gives me s equal 1 by 2. Similarly, the next factor is also 2s minus 1 equals 0. So equating it to 0, I get again s equal 1 by 2. So this is how I got the roots of the polynomials. 1 by 2, 1 by 2 or the zeros of given polynomial. Or the zeros, right? Okay, now let's go to the verification part. Now let me take alpha equal 1 by 2 and beta equal 1 by 2. Now we have to verify whether alpha plus beta equal minus b by a or not. Now first let's go for alpha plus beta. Alpha plus beta, it is 1 by 2 plus 1 by 2. That gives me 1. And minus b by a, you see it is minus of b here is minus 4. So it is minus of minus 4 divided by a is 4. So this is equal, you can cancel 4 and minus into minus you get a plus. Therefore you get minus b by a equal 1. So that we see that alpha plus beta equal minus b by a. This is the first part of our verification. The next part is alpha beta equals c by a. Now let's first find alpha into beta. Alpha into beta is 1 by 2 into 1 by 2 equal 1 by 4. And c by a equal to c here is 1 and a here is 4. So we get 1 by 4 again. Therefore alpha beta equal c by a. This is how we verify the relation between the coefficients and its zeros of the polynomial, right? Okay, now we'll move on to the third subdivision. Subdivision is 6x square minus 3 minus 7x. Before proceeding into the problem, you always have an eye on whether your polynomial given is in standard form or not. Now this is not in the standard form, so let me rearrange it as 6x square minus 7x minus 3 and then compare it with the standard form. Don't go blindly as it is from the given polynomial. You spend a second to check whether the given polynomial is in standard form. Then you write the values of a, b, c. So a is the coefficient of x square, b is the coefficient of x and c is the constant term, right? So a equal, b equal, c equal. Now we find two numbers whose sum equal b, that is minus 7, and product equal a into c, that is 6 into minus 3 minus 18. So when I factorize 18, I see that 9 2s are 18, right? Okay, but I need a minus sign. Okay, so any one of these terms, if the product is negative, any one of its factors must be negative. So either 2 or 9 should be negative. Before applying the sign, you check the sum. If the sum is negative, I have actually told you to place the sign with the bigger number. So now you check minus 9 into 2 is minus 18, right? And minus 9 plus 2 is minus 7, right? Okay, so we have got two numbers whose sum is minus 7 and product is minus 18. Okay, now let's go to splitting the middle term. So the middle term is minus 7x here. Let me split it as minus 9x plus 2x. So this is equal to, let me group the terms taking 3x common in the first two terms so that I get 2x minus 3. And from the next two terms there is no number common, so let me take just a plus 1 outside so that you get 2x minus 3. So here the common factor is 2x minus 3, so that the remaining factor will be 3x plus 1. Okay, now we have got the two factors. Let's equate them to 0 and get the roots. The first factor is 2x minus 3. Equating it to 0, I get x equal 3 by 2. And the next factor is 3x plus 1. Equating it to 0, I get x equal minus 1 by 3. Thus, 3 by 2 and minus 1 by 3 are the zeros. Go to the verification part, taking alpha equal 3 by 2 and beta equal minus 1 by 3. Right? Now we'll see what is alpha plus beta. Alpha plus beta equal 3 by 2 minus 1 by 3. So this is the LCM will be 6. So that you get 9 minus 2, that is 7 by 6. Now this should be equal to minus b by a. Let's verify whether it's equal or not. So minus b by a is, this is equal to b is minus 7. So it is minus of minus 7 divided by a is 6 here. So it's equal to minus of minus 7 is plus 7. So it's plus 7 by 6. So we have got alpha plus beta equal minus b by a. Then we'll go for the product. The product is alpha beta. So it is 3 by 2 into minus 1 by 3. So that you can cancel 3. You get minus 1 by 2. And this should be equal to C by A. Let's check it out. C here is minus 3 and A is 6. So minus 3 by 6 equal. We can cancel the term. So it's minus 1 by 2. So we have also got alpha beta equals C by A. So thus we have verified the subdivision is just 4u square plus 8u. So here you have A equal 4, B equal 8 and C equal 0. So in this case you don't have any constant terms. So we can directly group the terms. Okay, we need not go for sum and product. We can do it very easily by taking common terms outside from the two given terms, right? So that you can take a 4u common outside so that I get the remaining term to be u plus 2. So now we have got the factors directly without finding the sum and products, right? The factors here are 4u and u plus 2. So let me equate the first factor 4u to 0 so that you get u equals 0. Next, let's equate the next factor to 0 so that you get u equal minus 2. Therefore, 0 and minus 2 are the zeros of the given polynomial, right? Now, let's go for verification. In order to verify, let me take alpha equals 0 and beta equal minus 2. First thing, alpha plus beta, so it is 0 plus minus 2, that is minus 2. And this should be equal to minus b by a. This is equal to minus b here is 8 and a here is 4. So it is 8 by 4 on cancellation gives me minus 2. So we see that alpha plus beta equal minus b by a. Now we'll go for alpha beta. This is equal alpha into beta is 0 into minus 2, that is 0. And c by a is equal to, c here is 0 by a is 4, c by a equals 0. This shows me that alpha beta equals c by a is verified. Okay, now the fifth subdivision is t square minus 15. Here we see that a equal the coefficient of t square 1, b equal the coefficient of t. You don't have the t term here, so it's 0, and c equal minus 15. Right? Okay, in this case you don't have the middle term. So how we are going to proceed is, we are going to proceed by simplifying this square term and constant term into the form a square minus b square form, right? The first term is t square, is let it be a square, right? Minus, now this 15, let me try to make it as a square of some term. We know that this root 15 square is 15. So now I have expressed the given polynomial t square minus 15 as t square minus root 15 the whole square, which is of the form a square minus b square. And we know that the formula for a square minus b square is a minus b into a plus b. So applying this formula here, we have t minus root 15 into t plus root 15. So if you don't have the middle term, that is the linear term in the quadratic polynomial, you can just convert the given polynomial to the form a square minus b square and apply the formula a minus b into a plus b so that we directly get the factors. We need not go for sum and product. Okay. Alright, now we equate the factors to 0. T minus root 15 equals 0 gives me t equal root 15. T plus root 15 equals 0 gives me t equal minus root 15. Okay, now the roots here are root 15 and minus root 15 or the zeros of the given polynomial. Okay, now we'll verify the relationship between the zeros and its coefficients, right? alpha equal root 15 and beta equal minus root 15 say. Now alpha plus beta, let me add the two roots, so it's root 15 plus minus root 15, that's equal 0. And this should be equal to minus b by a, let's check it out. This is equal to minus b here is 0, so 0 by any number is 0 again. Therefore, we got alpha plus beta equal minus b by a. Now let me check whether alpha beta equals c by a. Alpha beta equal root 15 into minus root 15, that is minus 15. So now let's see what is c by a. C here is minus 15 and a is 1. Therefore, here again I get minus 15. That says that alpha beta equals c by a. Okay, now for the final subdivision. 3x square minus x minus 4. Comparing it with the standard form, we get a equal 3, b equal minus 1 and c equal minus 4. So we need to find two numbers whose sum equal minus 1 and product equal minus 12. So 12 can be factored as 3 into 4. But you need a minus sign here. So I have to include a minus sign to any one of the factors. But you see, since the sum is negative, I include it to the bigger number, right? So that I get 3x square minus x minus 4 to be 3x square plus 3x minus 4x. That is, I have split the middle term. Now let me group the first two terms by taking a 3x common outside so that I get x plus 1 as the remaining factor. From the next two terms, let me take a minus 4 common outside so that I get x plus 1 again. So let's take x plus 1 as a common factor so that the remaining factor will be 3x minus 4. Now equating the factors to 0, I get x plus 1 equals 0 gives me x minus 1. 3x minus 4 equals 0 gives me x equal 4 by 3. Therefore, minus 1 and 4 by 3 are the zeros. Now let me take alpha equal minus 1 and beta equal 4 by 3. So alpha plus beta, sum of roots equal minus 1 plus 4 by 3. The LCM here is 3, so I get minus 3 plus 4 in the numerator. That gives me 1 by 3. Now this should be equal to minus b by a. Let's check it out. Minus b by a is minus of b here is minus 1 and a is 3. So it's minus of minus 1 by 3. That's 1 by 3. That gives me alpha plus beta equal minus b by a. Now let's see alpha into beta. This is minus 1 into 4 by 3. That's equal minus 4 by 3. This should be equal to c by a. Let's check it out. C by a. C here is minus 4 and a here is 3. So it is minus 4 by 3 again. Therefore, we see that alpha beta equals c by a. This is how I have found the zeros of all the given quadratic polynomials using the splitting method, and I have also verified the relationship between the zeros and the coefficients. Hope you understood the problem. Thank you.